Let me introduce maybe a bit a different topic. It is the decision making for large-scale systems, and I will present some research areas of our faculty, and I will focus on some interesting decision making problems in which we are dealing with. So the University of Žilina, as my colleagues mentioned, we were originally established in Prague in 1953, but in 1960 we were relocated as a College of Railway Transportation into the Žilina, and from the time, we changed the name to College of Transportation, College of Transportation and Communication, and nowadays we are University of Žilina with 7 faculties. In the past, we were the only transportation university in the whole Czechoslovakia, and we are still focusing, even we are, for example, management science and informatics, we are still focusing on transportation mainly. I'm from Faculty of Management Science and Informatics. We were founded in 1990, and we are a bit special faculty because we have informatics and also management science, and this connection can solve or bring us opportunity to solve maybe some these interdisciplinary problems. We cooperate, or we are a part of the Industry Innovation Cluster, RICAIP Slovakia, that was founded just recently, a few months ago. And we also cooperate with the Automotive Industry Association of the Slovak Republic, where there are all these big factories for making cars like Kia, that is in Žilina, Volkswagen, and so on and so on. We also cooperate with some local companies and also some companies that are worldwide. What is our research area? We are focusing on decision support system for for extensive service systems. Usually there are transportation systems, emergency medical systems, and currently we are dealing with the problems related to the electric mobility, because it is the new area and there is a lot of research questions that should be solved. We have also colleagues which are dealing with the modeling of simulations in transportation, in biomedical applications. We have colleagues, as Mr. Gregor already said, we are cooperating with the Faculty of Electrical Engineering and Information Technologies on automation, IoT, computer vision, deep learning, and artificial intelligence. We have colleagues who are dealing with high-performance computing and low-energy computing with the memory stores. And we have colleagues that are working on reliability analysis, especially for the healthcare systems, and innovative management in economics in business. So what I want to talk about, I will start with the topic where I work. It is the optimal and reliable decisions for service systems, or designing of service systems. We usually work with transportation systems, as I mentioned. We usually try to develop or to solve some problem and develop some new algorithms to solve these problems, because the problem is to find usually the optimal solution. So we try to use or to create new algorithms that are based on the exact approach, or maybe use some heuristics approaches to solve these large-scale problems. And currently, or in past years, we are dealing with the problems of electric mobility. This electric mobility part is not from the point of view of making cars or something like this, but the creation of infrastructure, because there is a lot of problems that should be addressed. For example, the capacity of the network, of the electric network. The number of electric cars is still rising, so the infrastructure should be created in longer terms. So we developed some methodologies for the infrastructure planning based on data, or on big data from the past. and we try to find the relevant variables for the prediction of the demand of electric vehicles or for charging of electric vehicles. Classification methods for predict the trend of electric energy consumption, and methodologies for designing of charging infrastructure for a fleet of electric vehicles that are operating maybe in large urban areas or in general for some fleet of vehicles. We tested this approach for the data from Stockholm for the taxi cabs. We are able to solve these problems for approximately 1,500 vehicles in the system. There are also some special problems. Maybe this one, the scheduling of vehicles and scheduling of charging of the vehicles. This is mainly for the public transportation because the schedules should be fixed. But we are trying to plan the schedules for the vehicles and also planning of charging of the vehicles in some charging stations that are given. Here we used, we have the data set of approximately 80 vehicles. We are able to calculate this heuristically within tens of seconds. And we use also the various scenarios because with the electric mobility there are some other problems. For example, the different battery capacities, there is the influence of the outside temperature, for example. With the decreasing of the temperature, also the capacity of the battery is decreasing. And also the long-term battery degradation that should be also taken into account when the infrastructure is planning. And with this is also connected the second problem we are dealing with. It is not the planning of the positions of charging stations, but of the charging sections for in-motion charging, because this in-motion charging can be used, for example, in public transportation, but also in, for example, in this in manufacturing. So we try to develop the mathematical model to describe this problem that we want to we want to build some charging sections where the vehicle will be charged in motion. So we don't need to build some charging stations, and we can, for example, reduce the capacity of the batteries and the price and the weight of these vehicles, because when we have the fully electric plug-in vehicle, the capacity of the battery should be much higher. We have just some preliminary results here because we try to formulate it as a p-medium problem, because we have good algorithms for solving these kind of problems. But we also, with this approach, we can solve the problems with approximately 80 vehicles within minutes. Usually when we calculate some models using the mathematical programming approach, we simulate these results. Our colleagues on the department and on the faculty developed in 1990s the ABASIM architecture. It is agent-based architecture for simulating of traffic terminals and some also the factories and logistics in general. They developed the VLAN simulation tool. It is the generic detailed microscopic simulation model with the 3D visualization. They use the Petri nets for preparing the plans, for example, for vehicles, for some operations, also for workers what to do. And using this, they are able to simulate traffic terminals or buildings and stuff like this. In recent days, they are incorporating into this model the new part. It is called the PetSim. It is the simulation of the pedestrians with the behavior that they are not going one to each other. There are some social distancing implementations and stuff like this. And here is the short video. It is the video of our faculty that is modeled in the tool they already have, and they are able to model the buildings. There are some people who are walking from some higher levels, and this is the simulation of the evacuation of the building, but it can be used also for some other general purposes. This is also the next video that is in a simulation of railway station in Žilina. So you can see some people and they are walking in different directions, and they can be able to interact with each other, and they are also able to interact with vehicles because these models are connected together. This part I can skip because it was already mentioned by my colleague. So in the field of computer vision, our colleagues try to do the detection of objects, classification and tracing. They try to understand how this model works, especially with the neural networks. And using the deep machine learning, they try to automatically process the data and develop some automated methods. And this is one video of my colleague based on the video recording from the camera, from the mobile phone. They were able to detect the width of the traffic line. And this is maybe just for the information. It is the current research. It is the automatic train operation for the in-one H2020 project. So we are developing the software part of this automatic train operation. So thank you very much.